In this segment, we are going to talk about the concept of what is called as present value calculations or NPV calculations. Now, net present value of a particular investment or a particular project's cash flows are important parameters that get used in terms of evaluation of whether or not you would go and invest in a project or a particular investment, right? So let's understand this using a couple of examples, and then we look at a few variants around it, just trying to understand what are these numbers. The first one is assume an investment that pays rupees 10 every year for 8 years and pays back rupees 100 at the end of 8 years. Assuming that you are happy with an 8% return, how much would you be willing to pay for it? Right? So effectively we have an investment which gives you an interest of 10 bucks every year and 100 rupees at the end of the period. So this is the series of cash flows that you find, right? Now, expected return that you have is 8%. So present value is what you are going to consider. This should be present value of the investment. Present value of the investment is what we are looking at. Now, in a sense, what we are trying to say is that if, let's say, there was an instrument that was to give you 110 rupees next year and you expected a return of 10% from this, you would have been investing 100 bucks into this. How do we get this answer? 100, giving you a return of 10% should give you 110. Effectively, 100 is calculated by taking 110 and then discounting it by the expected rate of return plus 1, correct? Let's assume you had an instrument that gave you, instead of in 1 year, it gave you 121 after 2 years, right? So 100 invested at 10% and then again invested at 10% should give you 121, which means effectively what we see is 100, you would be willing to put in 100 in this if you were getting 10% return for 2 years. So you raise it to the power 2. So in a sense, what we are saying is we are going to discount each of these cash flows by a 1 plus R number, R being the expected rate of return. So 1 plus 8% in our case, and the power for each of them to calculate the present value is going to be the year in which the cash flow is going to come. So effectively, we're going to divide this 10 by 1 plus 8%. We're going to divide this 10 by 1 plus 8% to the power 2 and so on and so forth. Correct? So 10 divided by 1 plus 8%, 10 divided by 1 plus 8% square, 10 divided by 1 plus 8% cube, and you keep doing it till the last cash flow, which is 110 divided by, so you do this, and then the last one is 110 divided by 1 plus 8% to the power 8. That should be the value that you should get. So let's do this calculation, right? We will take this number. So let's write present value and let's take 10 divided by, open two brackets, 1 plus the rate of return, which is 8%, freeze it so that when we drag down it does not move, raised to the power, the first cash flow is to be raised by 1 year, right? This is going to happen at the end of the first year. So we raise to the power 1 year, we get a number of 9.25 something. Let's format it, that's 9.26. And I can just simply drag it down all the way up to here. So this becomes D11 into 1 plus 8% raised to the power, divided by 1 plus 8% raised to the power 2. This becomes D12, which is 10 divided by 1 plus 8% to the power 3, and so on and so forth till the last one, which is 110 divided by 1 plus 8% to the power 8, right? Now, if I do a sum of all these numbers, that should ideally be the price I should be willing to pay. 111.49 is the price that I should be willing to pay for this particular instrument. Nothing more, nothing less if I want an 8% return. If I want a 9% return, I would want to pay even lesser, which is 105. If I want 10% return, we will see this number becomes exactly 100. If I want 11% return, I should be paying 94, right? So what I pay defines what my return is going to be, because these numbers that I'm going to receive are fixed, right? Now, is there a smaller way to find this out? So what we have calculated just now is what is called as the present value. Addition of all these should give me the present value. So there is another method to find this out, which is called as net present value. All I need to do is in the components, I need to put in the rate, which is 8%. And then for the values, I need to just select all these values. It automatically assumes that the first value starts at the first year, and then so on and so forth. And then you press enter, we get the same result, 111.49, which is what we had kind of gotten earlier as well. So net present value as a function also gives you the same result, which is essentially what is the price that you're willing to pay. If I change this to 9%, we'll see both the numbers will change automatically. If I change this to 10, both of them will change. If I change this to 12, both of them will change. Depending on what is my required rate of return, my actual value of the instrument that I would want to buy out is also going to change. Let's add borders to this, and that's the solution to our problem, which is what is the value that we should be willing to pay for it. That is 111.49. If you pay anything more, the return is going to be lesser than 8%, right? So that's the first solution to an NPV problem. Let's now look at another example where, let's say we say that a project would entail an investment of 1200 crore and its expected returns in terms of cash flows is as given below, right? Assuming that the company wants a 15% return should they undertake this project. Now let's look at the series of cash flows. This first number here is actually 1200, which is the investment. So if you make this investment, these are the cash flows that you generate out of the project, right? So that's the project appraisal that is going to happen. Once again, what you need to see is that at the end of this process, effectively what's being said is that how much should you be willing to pay for this as a series of investment, assuming a 15% return. If that number is more than 1200, which means you should be paying more than 1200, but you end up paying only 12 as per this, you should immediately take the project because you are paying lesser. If that number, however, is less than 1200, then there is an issue that comes in, right? So let's do and solve this in this mechanism. What we are trying to find out is what is going to be the present value, and we will solve this also both the ways. So present value of the cash flows, remember 300 divided by 1 plus 15%. 15% is to be frozen, raised to the power 1, and you drag it on the right hand side. That's the present value of all these investments put in. Let's format all of them. And what is the present value of cash flows? That's equal to the sum of these 5, right? We find that the present value is 1186, which means if your expected rate of return is 15%, you should be ideally paying 1186 for this, but what we are paying here is 1200. So that doesn't make sense. You shouldn't be paying this much. We can also find out present value of the cash flows using the NPV method, which is 15% comma this series of cash flows, and that also works out to 1186. I'll remove the currency bit here, and that works out here as well, right? It says some error because it is at removing this cell. Now technically you could also do NPV using all these cells together, but that's an important premise that you need to understand in NPV. Remember, NPV only takes the cash flows as arguments. And the assumption of NPV is that the first cash flow is at end of year 1. So if I put 1200, 300, 200, 300, 400, 700, it will put in all these numbers as minus 1200, 300, 200, 300, 400 and 700. But its assumption would be that this is at the end of the first year, second year, third year, fourth year, fifth year and sixth year. There is no mechanism of saying this is at the 0th year. So because we are using NPV, we use it only from here to here, and then we check whether this makes sense or not, right? Now, if the total NPV of the project, right, which you can find out here, let's say we write what is the total NPV of the project. We write that down here, total NPV of project, that is equal to minus 1200 plus 1186. If positive, then accept. Right now, let's look at various conditions here. When can this become positive? Either the cash flows increase. So let's say if the first year if the third year instead of 300 was 400, then we find that this becomes positive, right? Which means the present value of the cash flows at a 15% expected rate of return becomes more than 1200. If positive, then you should accept, right? Let's actually code this portion as well. So the term that we have written here in English, which is if positive, then accept, we will code it in Excel, which is if this number is greater than 0, then accept, else reject, right? And you see we accepted. And in our initial case, we had 300 as the project number, so we had to reject it, right? Now let's assume the company finds a new source of funding, which is available instead of at 15%, at 14.5%, right? Because their cost of funding goes down, they should be okay with this return. So you find that at 14.5%, this suddenly becomes positive. Now, how does this work? My expected return from the project is just higher than what is my cost of raising this money. I can raise 1200 crore at 14.5% and then make this set of cash flows and still end up making 3 crore at the end of the year, right? If the expected rate of return goes down to 14%, that becomes even more positive. Right? Now this brings us to an interesting point, which is, I will write down the question here, which is what is the rate above which we can take the, below which we can accept the project, as in what is the rate of funds or cost of funds below which I should be able to accept the project and above which I will not be able to accept the project, right? So that maximum rate is that we have to find on which I can take the funding. So maximum rate of funding for project to be viable. There must be some rate here, right? If I change this to 14.6%, it rejects, and if I change this to 14.5%, it accepts. So between 14.5 and 14.6, somewhere this number has to come in. This is given by a number called IRR, or internal rate of return. I can solve for the IRR. I can take this set of values in the IRR, and that will tell me what is going to be my exact percentage return. So let's do that. It's IRR, and you select this series of cash flows. In IRR, you can use all the cash flows. It assumes the first one is a negative one. It needs one negative at least. And you get 15% as IRR. Open this up. 14.58% is where the break-even point comes. Beyond this, if the cost of project funding goes above 14.58%, you will realize that the project becomes, you will not accept the project. If, however, the cost is below 14.58%, which is then what becomes your expected rate of return, you will be accepting the project. So that's the important concept around IRR and NPVs, and essentially this is a concept that will get used again and again in all sorts of combinations in terms of corporate finance and projections on any kind of investments that you're doing, trying to find out what is the correct value that you're going to pay for any particular instrument, right? The concept of IRR is something that you need to be careful about and also look at it in the context of how do you accept a certain project or not. So if the IRR is greater than this cost of funding, essentially, if the IRR is greater than this cost of funding, then essentially you kind of end up accepting the expected return. Then you get, you accept the project. If the IRR is less than this, so if we were looking at a number of 14.6% here, then you reject it, right? So the formula becomes if IRR is greater than this, then you accept it. If IRR is lesser than the expected return from the project, then you reject the project, which will in a sense mean a positive or a non-positive negative value for the NPV of the project, right? That's how you solve this particular question on NPV and IRR.